This is section 7.1, exploring quadratic relations. So here's the key ideas. The degree of a quadratic function is 2. The standard form of a quadratic equation is y equals ax squared plus bx plus c. So when I say that the degree is, that means that the largest exponent on x is 2. That's what it means the degree is 2. And we can put any value for a, b, and c, but a cannot equal 0. Because if we put a 0 there, the highest degree on x would just be 1, and that would be linear. The graph of any quadratic function is a parabola with a single vertical line of symmetry. Okay, so I have a couple graphs up here of parabolas, and you can see that this is a parabola, and it has an axis of symmetry of, if we put a line right here, it would cut it exactly in half. Okay, so the value in front of the x squared in this case is 1. So look what happens if we change it from 1 to 2. You can see that it has shifted. I'm actually going to delete this one so we have different colors. It has shifted. It has become a little more narrow. Let's see what happens if we put 3. Okay, what if we put something big like 5? Okay, it's becoming more and more narrow. Okay, what if we put -1? Okay, you can see that it has just now gone negative. I don't like the way this one looks. That's okay. Okay, what if we put -7? Okay, you can see that it now becomes more narrow. So the value of A seems to affect how wide or narrow it is and whether it's concave up or concave down. So that's the value of A. The value of B is this number in front of the x. So right now it's at 1. Let's see what happens if we put 2. Okay, what if we put 3? And if we put something big like 6? So that seems to decide up and down. What if we put a negative? What if we put -5 there? X squared minus 5x. What if we put plus, oops, -3? Okay, so you can see it's shifting in some way when we change the b value. Okay, now this c value of 1, you'll notice that this graph, the y-intercept, it intersects at 1. And if we change this value, if we change that to -1, let's watch what happens. If we change that to -1, you can see that it now crosses at -1. If we change this to -5, you can see now where it crosses. If we put +2, look where, oops, I have to type it in right. +2, you can see it crosses at +2. Okay, so the values of A, B, and C shift the graph, and they summarize this in your textbook. Summarize it right here. Oh, if you do want to graph like this, I love using this. It's called desmos.com/calculator, and you just actually type in the equation. You can change the color and all of those sorts of things. Okay, so just to summarize what we did, a quadratic function is written in standard form where y equals ax squared plus bx plus c has the following characteristics. The highest or lowest point on the graph of the quadratic function lies on its vertical line of symmetry. So that's called its vertice. If it's A is positive, it opens up. If A is negative, it opens downwards. Changing the value of B changes the location of the parabola's line of symmetry. So when we changed B, it either went left or right depending on how we changed B. The constant term is the value of the parabola's y-intercept. So that C affects the constant. B affects the location of the line of symmetry, that red line right there, where you could cut it in half. And A decided if it was parabola up or parabola down, and also the width. Okay, there's a couple questions for you to try in this section.